Hello and welcome back to the channel. So till now we have got clear understanding of the Hadoop core systems. And in the previous lecture we have completed some exercise on MapReduce and I hope you understood it. So from this lecture we are going to start our journey and will explore what is Hive, why it is useful and how it works under the hood. So without further ado, let's get into it. So the first question you'll ask, what really is a Hive? So basically Hive is nothing but an open source project which is built on top of Hadoop for querying and analyzing large datasets which are stored in HDFS. So it basically is a data warehouse system, but it is not fully data warehouse. So it gives us the capability of working with structured data and we can run simple SQL operation on top of them. So what is structured data? I hope you already know. So if not, the structured data is nothing but a data which has some integrity. So the data will be stored in the row and column fashion. So the next question will be why we need Hive? Because we have MapReduce to process our data and get the desired result. But why we need Hive then? So let me tell you a short story to explain you a bit history of Hive. And I will guarantee you it will not boring. So just bear with me. So back then when Facebook was invented, it was struggling to store a huge amount of data because back then they were using RDBMS to store all their valuable data for data analytics and doing some complex operation on top of it. But it has its limitation and it is not that scalable for such large data sets. So Facebook was looking for a better alternative. So they have initially tried to use MapReduce. But basically, if you want to do any operation, you have to write complex programs which will need some advanced programming knowledge. Therefore, it will be a time-consuming process. So to solve these difficulties, data infrastructure team at Facebook came up with a solution and developed a tool called as Hive, which was invented to address all the issues which Facebook was facing with the petabytes of data. So these tools can be capable of running simple SQL queries which is then converted into MapReduce job to process the data which is stored in HDFS. So because of which there are some advantages which we are going to discuss now. So basically as Hive uses the language called as HiveQL which is very similar to SQL and you can do all SQL operations in Hive. So it will be easy to do complex operation on your data. So that is the first advantage. The second one was you don't need to write any complex MapReduce jobs for your data transformation needs. So you can simply submit SQL queries and do all the aggregations, sorting as well as different filtering on your data. And the next one was it automatically converts our SQL queries into series of jobs for execution on your Hadoop cluster. So it will take the parallel execution benefit of Hadoop cluster. So it will give you benefit of both the worlds. So you can run simple SQL queries such as RDBMS and also you can take advantage of parallel execution which is same as Hadoop cluster. So this will justify why we need Hive instead of MapReduce. But wait a minute, where this Hive sits on top of Hadoop stack? That we will see now. So this is the Hadoop ecosystem and there are a lot of tools, but don't worry, I'll be covering all the tools in this Hadoop tutorial. So basically as we're talking about Hive, so this is the Hive which sits on top of MapReduce. When we submit a query to Hive, it will convert it into a MapReduce job which will then communicate with resource manager which is Yarn, which is used for resource allocation purpose and it can do all sort of operation on our files which are stored in HDFS. So basically it uses MapReduce, Yarn and HDFS which are the core services of Hadoop. And you don't need to worry about writing complex programs for your data transformation. But you have to keep one thing in mind that Hive will only process the structured data which is stored as a table in your dataset. Hive also uses Hive Engine which is an optional processing layer for MapReduce. And the good thing is Hive is available and already set up in your Hortonworks sandbox. So we can use both the engines and we can see the difference. So as in the next lecture, we are going to execute our Hive queries. You will get a clear idea about the Hive engine as well. So now let's discuss about the architecture of Hive and how it processes the data. So for that, we will discuss about the major components of Hive. So the first one and very important one, which is Metastore. So Metastore is nothing but separate RDBMS which is used for storing metadata for each of the table and their schema as well as the location of that table. So basically metadata is nothing but data about data. It is just like an index for your database. So all this information will be stored in the Metastore. So this will help the driver for tracking the progress of various data sets which is distributed on the cluster. So what is driver, that we are going to discuss in a while. So this metadata will help the driver to keep track of the data, and it is very crucial. So our next component is a driver. So it acts like a controller and receives the Hive queries when the user submit queries on a web UI or a command line that we are going to see in next lecture. So the driver will start the execution of the statement by creating some sessions, and it also monitors the life cycle and the progress of that execution. So it gets the metadata information from the Metastore and will communicate with the MapReduce for executing our SQL statements. And it also have its sub-components such as compiler, optimizer and executor, which we are going to see now. So the first one is compiler. So as the name suggests, this compiler will use for compilation of your HiveQL queries. So HiveQL is nothing but a language which is used by Hive. So it is similar to SQL. So this compiler will convert the query to the execution plan. So this plan will contains the different tasks which needs to be performed, and it also contains the steps which are needed to be executed by the MapReduce for getting the desired output, and it converts the query to the direct acyclic graph. So what is direct acyclic graph, which or DAG, which we are going to see in a bit. So the next component is optimizers. So optimizer, as the name suggests, it will provide the various transformation and execution plan to provide a optimized DAG, which is direct acyclic graph. So what it does is it aggregates the different transformation together and converts a pipeline of joins into a single join, which is more efficient, and it will give us the better performance. And it also splits the task, such as applying a transformation on the data before the reduce operation for providing optimized performance. And the next component is executor. So once the compilation and optimization is completed, the executor will execute the task, and it also takes care of pipelining the task. So this is how the main components of Hive works under the hood. And the last one are nothing but the different approaches of running the Hive statement. So the first will be the command line interface will provide a user interface for external user to interact with the Hive. We also have the Thrift Server, which allows external clients to interact with Hive over the network, which is similar to the JDBC or ODBC protocols. And the UI will nothing but the Hue or Ambari, from where we can submit a query in a very interactive manner and will get the output on the UI itself. So these are some ways by which you can submit a Hive query on your Hadoop cluster, and we are going to see them one by one from the next lecture onwards. So this figure will give you all the idea of how Hive will process your data. So first, through the CLI or Hive Thrift Server or the web interface, we will submit the queries to the driver, and then driver will have the parser, executor and optimizer, which will get all the necessary information for Metastore, which is nothing but a relational database which stores all your metadata. And then we will have the planner which plans the execution. Then the optimizer will optimizes a plan and creates a DAG graph, and then executor, which will communicate with MapReduce and convert our job into a MapReduce job, which will then process our data and we can get the results as desired. So at the end, let's discuss some basic features of Hive. So as you know, Hive will be used for data analytics in a very easier manner, as you don't need to write a complex code, and you can use a simple SQL-like query to do all the data analysis. The second one is it is scalable, familiar, and extensible. So as it uses the HDFS to store its data, it will be a highly scalable system as it stores the data into distributed manner. And also it uses SQL-like language, which will be very easy and familiar, and it doesn't need some expertise in programming. The next one is it uses the partitioning technique to improve the query performance. So it is a very huge topic, and we can discuss that in the separate tutorial which is dedicated to Hive, where we can discuss these techniques in detail. But simply, partition is nothing but splitting your data into more manageable parts. This knowledge will be suffice for this tutorial. The next one is HiveQL doesn't require any programming language, so you don't need to write any complex MapReduce job, and you can simply write a SQL query which will be automatically converted into a MapReduce job for you. And the last one is it will process the structured data with ease. So as I earlier said that Hive will only process the structured data. So structured data is nothing but a data which is stored in row and columnar format, which has some specified metadata and integrity. So whether you have a text file or a Parquet file or any other file format, you can easily run SQL queries on top of that data. So these are some features of Hive and how Hive will be useful to get some insights from your data. So from the next lecture, I will be showing you how we can use Hive and how we can submit SQL queries on the data stored in Hive. First, download the required data, and we can create some tables and run some join condition and also use some complex operation. And I will also introduce the test engine, which will be a optional for MapReduce for processing your data. I hope you like this lecture, so please subscribe to our channel and also ring the notification bell to get the latest updates. And don't forget to follow us on our social media that I have linked in the description below. Thanks for watching.